So we will start new chapter fluid mechanics today. Fluid mechanics has two parts in it, fluid in static and fluid dynamics. We'll start with fluid static, which is also known as hydrostatic. All of you must have studied this hydrostatic part in your lower class physics. We'll only continue from the basic of this fluid. What is fluid particles? As we all know that in every material there are some forces in between the particles or molecules inside the material. If you talk about solids, the force between two particles or two molecules are strongest. In liquid, the force is smaller, and in gaseous particles, the force is very small. So in fluid, we will mainly in this chapter we will discuss about liquids. And what about that forces? As I have told you that the force between the molecules are more than that of the gaseous molecules, but it is definitely less than that of the solid molecules. Now, three types of force are there that we can exert on any body. So let us talk about those forces first. As you can see that suppose we have a solid body here and we can apply a force from the top. This is normal to the surface. This force is known as compressive force. Why? Because after uh, this force, this body will somehow contract its shape, right? If we can compress that body by a few, by whatever the small distance it may be. It depends on the property of material that how much we can compress it. This is our tensile force. The same material, if I fix its base, in all the three cases, I have fixed the base, right? Fixed base. So all of them is a fixed base, right? So if I apply a force in the second case, you can see it is a tensile force. And in this application of this force, you can see that this length or the height of the material can be increased. And the third type of force is new to us. It is known as shear force. You can see the shear force is applied on the surface but parallel to the surface, parallel to the base, not perpendicular to the surface area. It's parallel to the base. And in application of that shear force, the particle will, this body will change its shape like this. It will get twisted. If the base is fixed, it will get twisted. So basically, if you talk about a solid body, then solid body will oppose all of the three kinds of forces. If you exert a compressive force, internal force will be developed inside the solid that will oppose that compressive force. Similarly, if you apply a tensile force, internal forces will be developed inside the solid so that it will oppose it. Similarly, in this case, if you try to change its shape, then this body will also oppose it. For a solid body, this will happen. What will happen for a liquid or rather a fluid? Suppose now consider this to be containers full of liquids, right? These are containers full of liquids. And there is a piston. There is a piston that is fixed at the top. Not fixed. This piston can move placed at the top of the liquid. If I say it is a liquid. In case of an ideal liquid, you cannot compress the liquid. But definitely in case of fluid, we can say that we can compress it. So can I say fluids can oppose the compressive force? Definitely. Fluid, if you apply a compressive force on fluid particles, they will oppose it. Right? Fluid will try not to be compressed, just like a solid body. But if you apply a tensile force, will that fluid particle can exert any force?
No.
If it is a liquid, you exert a upward force to the piston, fluid will never going to oppose you for a tensile force, right? So fluid will not exert any reaction on the tensile force. Definitely for an compressive force it will. What will happen to that shear force? If you apply a shear force to the fluid, what will happen?
Not, it will not exert any internal force.
In that case, you will find an interesting phenomenon that you can consider this fluid to be made of different layers. What you will see if you apply a shear force, you will see that the layers will slide one over another. Yes or no? So if you apply a shear force, this layer which was initially here will now be here. So basically the fluid layers will flow along the direction of shear force. That is why its name is fluid. Right? Sometimes it says that fluid is named because it flows. But it flows in which direction and because of which force? Not because of compressive and tensile force. The fluids flow along the direction of shear force. So if there is any motion in the fluid, definitely it must have that you are exerting a net shear force on the fluid surface. A shear force must be there. But if the fluid is at rest, definitely this shear force is zero. Otherwise, fluid particles will flow along the direction of shear force. Right? That we need to remember. That fluid cannot exert here this normal reaction force. Here it can exert opposing force. It can oppose it. It cannot oppose it. But for this case, the fluid will flow along the direction of the shear force. So if I now tell what are the properties of fluids, there are three types of forces we can apply on any object: tensile, compressive, and shear force. In a closed container, we can apply compressive force and fluid will oppose that. But fluid can't resist tensile force. Whereas fluid particles flow in the direction of shear force, right? Shear force. So you should always remember in this chapter, if you remember this property of fluid, right, in case of fluid flow or in case of fluid static, it will be very much helpful when we will try to analyze few situations. That no shear force means fluid will be at rest, and if there is a shear force, definitely fluid particles are going to move along that direction. Is that slide clear? What is the basic difference between fluid and solid particles? I'm not going into the deep discussion of that intermolecular space or something like the adhesive forces or like that. You have read out these things in chemistry classes, or what whenever needed we will discuss which one is needed. But right now, not all these concepts are needed because we are actually not considering the microscopic properties of fluid here. We are not interested what force is exerted by one fluid particle to another fluid particle. We are only interested in the macroscopic property of fluid. That means how the entire fluid is going to move as a system, right? So that is why we are not going into the intermolecular or the intramolecular properties of fluid. All right, if it is clear, then we will move to the hydrostatic part. It says that we will hydrostatic with respect to the container. Remember, with respect to the container, the fluid should be at rest. It may have that container is moving with some acceleration, velocity, whatever it may be. But whenever the fluid is at rest with respect to container, we say it is hydrostatic. Right? If your container is a pipe and fluid is flowing inside the pipe, then it is not a hydrostatic condition, because with respect to the pipe, the fluid particles are not at rest. But if you have a container, if you have a box, or if you have any vessel that is moving with acceleration, but fluid is at rest with respect to that vessel, it's in hydrostatic only, right? So first, yes, tell me if there is any doubt.
No, so in like if a container is moving and that it is not completely filled with fluid, means there exists a space over it. So the fluid will means bend in, means change its
Yes,
surface.
definitely. So that
So
transient period is not hydrostatic part. We are not going to study that transient period here. But once if the acceleration is constant, after some time, after the fluid gets its proper shape, that shape will remain constant. So that part we will study in hydrostatic when it has become a steady state with respect to the container.
okay, sir.
All right. Okay. So what is hydrostatic pressure by any liquid or fluid, that I will first discuss here. Pressure, as we all know, that pressure is force per unit area. Pressure is force per unit area. Force should be normal to the area. Force is normal to area, right? Definitely not a shear force, right? Force per unit area is pressure. And how do I measure the pressure? Definitely, if I have a given area, the force is same, I will just divide. Otherwise, if forces are different at different positions, I will measure the force at a particular point. Now, how do I find the force? If pressure and area is given, then remember that if this is an area and I know the pressure at different points on the area, suppose it is constant, then I will measure the force always perpendicular to the area. That force is always perpendicular to the area. Now, the question is, in which direction I will take the force? The answer is you can take force in either of the direction. In both the direction, the force is there. But this force can be exerted by different materials. Materials. Suppose on this side of there is a material 1 and this side the material 2. So this force F prime is provided by material 2 on this surface, and this force F is provided by material 1 on this surface. Yes or no? This force is by material 2 and this force is by material 1. So if there is air and water interface, then you can find what is the force at any point if I know the pressure. Just multiply it by the pressure and this area, I will find the force. Remember that force is always perpendicular to the surface. Right, that's all. But pressure, as you can see, that if I ask you that what is the direction of pressure, does it have any direction? Pressure at this point, what is the pressure? Force is equal to P into A, right? Force is equal to P into A. Now you can consider another thing. If I consider a surface passing through the same point P, but the surface is like this, P point remains the same. with the point P, how much surface I can consider? I can imagine infinite number of surfaces that are passing through point P. Yes or no? Now if I ask you what is the force at this point P, now you will definitely not say this is the force on this point P. Rather you will see that I will drop a perpendicular to that surface and I will say this is the force on that surface. The same point, but the force direction is different. So that is why pressure is not a vector quantity. Because would it had been a vector quantity, I will find a unique direction of that force. But at this point, the pressure is a scalar quantity rather. You can say pressure is a scalar quantity. Rather, the term scalar is also not applicable. Pressure is a tensor quantity basically. Pressure is a tensor quantity. Tensor quantity. Do you remember what I have told you about tensor quantity? In the last chapter, I have a bit, I think for a few seconds only, I have discussed what is tensor. Do you remember one important property? What is tensor? What is the basic difference between tensor and a vector?
So
Like
tensor has three directions.
tensors are different directions, not three only. Tensors may have, vectors can only have one direction, unique direction, but tensors are vectors which are having different directions. So pressure can also be considered to be a tensor. Not pressure, but rather it's also known as force per unit area. This term force per unit area is not always known as pressure. It's known as stress also, right? Stress, pressure, force per unit area is also known as stress. They are the same quantity, pressure and stress, right? So pressure as well as stress both are nothing but tensor quantity. Here we will talk about pressure only, not stress. Stress we will discuss in other chapter, elasticity. So pressure is a tensor quantity which has multiple directions. Multiple directions. Any direction you want, you can take. I want this direction, you can take. But the force will be perpendicular to this area. Anyone else will take another area through the same point, and the force will be perpendicular to that area, right? And the pressure is the same. So pressure has multiple directions, that is why it's a tensor quantity. Otherwise, if in your syllabus someone asks what is pressure, definitely it's not a vector quantity. It does not have a unique direction. So you can say it's a scalar if only options are scalar and vector available. Otherwise, if tensor available, definitely you mark the tensor quantity. Right? Definitely, I'm sure that it is not in your syllabus, so no one is going to ask about tensors. Okay, so we are not actually interested what is that pressure, whether it's tensor or vector, but we are actually interested in this force. In this entire chapter, we are finding pressure because of we have to find the force, right? So let us now calculate what is the pressure at any point inside a fluid at rest. I'm talking about hydrostatic, remember. I'm talking about hydrostatic. Now, for the time being, I will consider container as well as the fluid, both are at rest, right? Container is at rest and fluid is also at rest. So suppose this is the container. I'm drawing the container, right? And suppose this is the fluid level, right? This is the container, this is the fluid kept inside the container. Outside is atmosphere. I will assume atmospheric pressure to be constant here, right? I will assume atmospheric pressure to be constant here because atmosphere is so long, so high that within that interval, within that small height span, I can assume atmospheric pressure to be constant. Here it is P naught, outside here it is also P naught. Everywhere the atmospheric pressure I will assume to be constant. Until unless this container is also very high, very long, right? That we will not take. So this is pressure P naught, atmospheric pressure. I am interested to find out the pressure at some point. Suppose this is Y. at a height y, I'm interested to find the pressure of the liquid. So the method that we will use is, as I have told you, that we are not going to analyze microscopic property, right? We are again going to use a macroscopic. So I will take a small element, not a molecule. I will take a small element of that fluid. That element may be a cylinder, or you can take it as a cube also. I will rather take a cylinder like this, right? A small elemental fluid, right? It is a fluid element. You can say it is a fluid element. Fluid element. The method I am going to use here will be using several times in the course of physics. So if I draw the free body diagram of that small cylinder now, let us take the cylinder outside, right? Although it is very simple to analyze. Let us take the cylinder outside and let us assume that the height of the cylinder is dy, right? Or delta y. Rather take it a delta y. And the area of the cylinder is A. What is the pressure at this point? And what is pressure at this point? Are the pressures same at both the levels?
No.
No.
No, sir.
At the same level, liquid pressure is same. Same horizontal level, pressure remains same. Not same vertical level. Vertical levels are different. Vertical levels are different. Here horizontal levels are different. So that has a height delta y. If I say that pressure at this level is P of y, because I am interested to find the function of pressure as y. Y means pressure as a function of y. What is pressure at this point then? If I say that this is pressure at y, what I can say the pressure at this point?
So P of y plus dy.
Y plus delta y, yes, good. Now look, now I am going to write down the force direction. Very careful that on this body, I am only interested to find out the force by surrounding. So on this area, the surrounding is the above liquid. So that liquid will exert a force upward or downward. That liquid at the surrounding, that will exert a force on this particular area, right? Definitely it is going to push it downward. Yes or no? So if the pressure is P of y plus delta y, I can say that the force is P of y plus delta y into A. Similarly, the liquid that is surrounding this liquid will exert a force in this direction, right? As I have told you that this two medium will exert a force in this direction. One medium will exert a force in this direction. So here the medium 2 is this. So this medium will exert a force. It will push it. This medium will also push it. So the force is P of y into A. And there is a weight acting downward. Because the gravitational force, gravity is acting downward, G. And as it is at rest because of the hydrostatic condition, it is at rest. So in equilibrium, what equation I can write? Can you see what equation I can write? In equilibrium, these forces must be equal or not. The net force must be 0. So can I write P of y plus delta y into A plus W is equal to P of y into A? Take P of y into A in this direction, in this side. So P of y plus delta y minus P of y into A is equal to minus W. Can you tell me what is the weight of this small fluid element?
Sir, rho A delta Y.
If its density is rho, which I have taken uniform everywhere, so this mass has a volume of A into delta Y multiplied by density is the mass into G is the weight. Yes or no? Now you can cancel A and take delta Y in this denominator, minus Py divided by delta Y. Is it equal to minus rho into G?
Okay, I found this on the.
Now, if this delta Y has a very small value, can I put a limit delta Y tends to 0? And can you see what is that equation? Mathematically, what can I write this one? Have you done this mathematical expression?
Sir, dp dy.
dp by dy, limit
Yes, sir.
of delta y tends to 0, right? Limit of x tends to 0, if delta x tends to 0, f of x plus delta x minus fx by delta x. Is it f prime x? Yes or no? So I can say this is dp by dy is equal to minus rho g. Have you got it? So as I move upward, why negative? Because as I move upward, the pressure actually increases or decreases?
Decreases.
Decreases. Now you can find what is the pressure at any depth. Suppose at a depth h I am interested to find pressure. So I can now integrate this minus rho g into dy. And if rho is a constant, I can take it outside the integration. And at y equal to which level I know the pressure? Can you tell me? At y equal to which level I know the pressure?
H, where H is the height of the liquid column.
Yes, if the h is the height of the liquid column, capital H, when y equal to capital H, I know the pressure is how much? P naught?
P naught.
Yes,
P naught.
P naught. And suppose I want to find out the pressure at any this level, right, where this is small h. So this height is capital H minus small h. I want to find the pressure at capital H minus small h level. So you can see that P will be equal to P naught minus of rho g capital H plus rho g small h minus rho g capital H. So this will be your answer for the pressure at any height A, at any depth h, P naught plus rho g h. Although it seems very simple, but you have to use this formula, right? Even if you do not use this formula, you know from its from your basic knowledge that the pressure inside a fluid is rho g h, where h is the depth, right? But if rho is variable, you cannot use that pressure is rho g h. Then this equation will be useful for you. This is the differential equation, or this is the pressure gradient. Pressure gradient means pressure, how does it change with height or with depth? That equation is useful to you. Have you understood this entire discussion? Here container is at rest.
Sir?
Container is at rest. Yes, tell me.
Sir, can we consider the y from the surface also?
Also you can consider, no problem. If you consider y from the surface and dy, then again dy and y should have the same direction, that you should understand. If y is from top means towards downward, then dy also has to be towards downward. So you can also take that. Then in lower case, lower pressure will be P of y plus delta y and upper pressure will be P of y. Right? In that case, your dp by dy will be positive, because as y increases, then pressure will also increase.
Yes, sir.
Right? No problem. You can also assume in that way. Anyone, do you have any doubt in this discussion? Because we are going to do this discussion again and again. This formula is very useful, right? For next, I think this entire class 11th or class 12, in all the chapters, we are going to use this formula, mathematics, right? In order to write down it in a differential form. Okay, I don't think there is any doubt. So we'll move forward. Now it's a simple question I have only written. Try to find the answer. A liquid is kept inside a cylindrical container having base area A up to a depth h. The density of the liquid changes with the height from its base is rho naught into 1 plus 2y. Right? Find the gauge pressure at the base and force by the liquid on the base. Force by the liquid on the base. दुबारा liquid होएगा. What is gauge pressure? Gauge pressure is pressure other than the atmospheric pressure. Net pressure is atmospheric pressure plus liquid pressure. Gauge pressure is only pressure by the liquid.
Sir, it will be rho naught. Oh, it is given by now.
It is rho naught divided by 1 plus 2y. It's not multiply.
Yes, sir, that one.
Sir, gauge pressure rho naught into ln 1 plus 2h.
Liquid is there up to a height h. So depth h. So this depth is h given. Right? So gauge pressure here is 0. I have to find pressure at this point. Right? I can take at a depth, at a height y, and I can find what is dp by dy minus rho g. So dp equal to minus rho naught by 1 plus 2y into g into dy. When y is equal to h, p is 0. And when y is equal to 0, I need to find p. So p is equal to minus minus plus rho naught into g by 2 ln of 1 plus minus the 1 plus 2h. Yes or no? Is that the gauge pressure you have got?
Yes, sir.
And the force is nothing but pressure into area. So that is rho naught g by 2 a into ln 1 plus 2h. These are the answers to this question, right? So now if I, this is a interesting phenomenon which is known as hydrostatic paradox. You can see I have kept the same liquid up to the same level in 3 different containers having different shapes, and all of them are kept on weighing machines. So you need to compare the readings of the weighing machines of 1 to 3. What is force by the liquid on the base and the normal reactions on the base by the fluids between these three containers.
So is the base area of all the containers same?
Same, yes. The base area is the same of all the container.
So will it be same for all?
The force by liquid will be same for all.
Yes, sir. It will be same for all.
Yes. Force by liquid is same for all. What about the weights?
Sir, all are same. The weight, force by liquid, and normal reaction all are same.
No.
So the weight will depend upon the shape of the container and the amount of liquid present.
Yes. Definitely from the diagram it is clear that weight of 1 is greater than weight of 3 and that should be greater than weight of 2. Which container has more liquid? Container 1 has more liquid than container 3 and container 2 has a minimum amount of liquid in between these three. Yes or no? If I neglect the weights of the container, here we can neglect the masses of the container, then the weighing machine will only read these weights. Yes or no? Weighing machines will only read the weights. So this weight is definitely more than this weight and this then this weight and last is this weight. Right?
So the normal reaction is same.
What about the normal reactions?
See, the weights are the normal reactions.
Normal reactions?
I said the weighing machine will read the weight of the normal reaction.
Yes. What the weighing machine will read? Weighing machine will read definitely the normal reaction by what? Weighing machine will read the normal reaction by what? Normal reaction by the liquid or normal reaction by the container?
By the container.
Normal reaction by the container, right? So weighing machine will force on by the liquid on the base and normal reactions on the base by the fluid. The question is not normal reaction on the weighing machine by the container. If the question would normal reaction by the container on the weighing machine, then which will have a largest normal reaction?
So one.
1. If I say that N is normal reaction on weighing machine by the container,
Then N1 is greater than N3 greater than N2.
N prime, then N1 prime is definitely, because weighing machine will only read what? Only read the normal reactions. But if I say the question is N is the normal reaction on container base by fluid,
Then it should be same.
it
because
is the
pressure
same. N1 is equal to N2 is equal to N3. Why? Because this normal reaction only is what? Pressure multiplied by area,
Yes, sir.
right? So what is the pressure at this all these points? Pressure is the same, rho GH multiplied by area. It is the same for all the liquid. But why n is same, but n prime is not the same? It lies in the free body diagram of the fluids. If you draw the free body diagram of the fluid or container, suppose I am drawing the free body diagram of the fluid. Okay, let me draw the free body diagram of this fluid. What are the forces I will show? What are the forces I will show here? Look, this fluid has its own weight, right? This container surface will exert a normal reaction to the fluid base. This is N. This normal reaction on the container base by the fluid is the same normal reaction by the container surface on the fluid, yes or no?
Yes.
Is there any other force that the fluid is experiencing?
From the sides, it is also providing a normal force.
These side forces are also there to normal reactions force, right?
But so they will be balanced.
Yes, they will be balanced. Not they are balanced in vertical direction. Suppose this is R and this is also R. So what equation I can write? Can I say that this side forces will have two components in vertical direction? So they are horizontal components to what? Cancel each other.
Yes.
But their vertical components will add up to RV. 2RV plus N is equal to W1. Yes or no? Look, if I say 2RV, the vertical force with N is equal to W1. N is the same for all of them. As I am adding something with N, so W1 is more. Just like the second figure, if you draw the free body diagram of the second liquid, what forces you will show? W2 is downward, normal reaction is upward, and these two reaction forces are there. Now here the RV forces will have a component in which direction? R have a vertical component in downward direction. So when you will write this equation, what you will write? N minus 2RV is equal to W2. And when you draw the free body diagram of the third one, then R will get cancelled out. W3 is downward, N is upward, and R will get cancel each other. So N is equal to W3. As N equal to rho GH into A for all, can you see that W1 is definitely greater than W3, which is greater than W2, because in W2 you are subtracting something from N, in W1 you are adding something with N. Have you got the explanation? If you now draw only the container free body diagram, what you will draw the container free body diagram? For the container, if you draw the container free body diagram, what are the forces acting on the container?
So the R, the N, and the weight of the container.
Not container does not have any weight. So I can say this normal reaction is back on the container. Yes or no?
Yes, sir.
this R will back on the container, this R will be back on the container, and there is a third force, that is the normal reaction between the container and the weighing machine, N prime, that I have told you. Yes or no? So when
Can you please repeat?
I'm drawing container free body diagram.
Okay, sir.
All these three forces are due to the liquid, and the fourth force is due to the weighing machine.
Yes, sir.
So if you equate this N prime, what you will get? You will get N prime is equal to N plus 2RV, which is nothing but W1.
Yes, sir. Understood.
Right? So N1 prime is equal to W1. Similarly, N2 prime is equal to W2, and N3 prime is equal to W3. So the order of N1 and N2, order of N prime is the same as W, but normal reactions on the base only depends on the force on the base, and that is nothing but rho gh into area. Remember, this normal reaction on the base of the container by the liquid is only rho gh into area, the base area multiplied by the pressures. That is why it is the same for everyone. Right? And if I ask you what is the force by the liquid on the base, it is the same also. The force by the liquid is nothing but the normal reaction. Right? Force by the liquid on the base and the normal reactions, they are the same. Everywhere they are the same. Also, N is equal to force by liquid on container base. Right? But N1 prime will be different. N1 will be the same. This is an interesting hydrostatic paradox. Right? Even if the base has the same normal, but due to the side normal forces, actually the readings are different. Now these are few questions on U-tubes. U-tube means this will be a U-shaped tubes kept in a vertical plane, and we will use this concept only. A single concept is used in this U-tubes. Very simple questions are there. The concept is that for a single liquid, pressure is same at same horizontal level. Right? So suppose a liquid is there, right? So this level and this level will have the same pressure if below this line there is only one liquid, a single liquid is there. The condition should be a single liquid should be there. If there are two different liquids, one liquid below this line, another liquid below this level, then I cannot say the pressure is same. You have to find one single line below which there is one single liquid there. Density has to be the constant, same everywhere. Then you can say that the pressures at these 2 points are the same. P1 is equal to P2. If below this line only a single liquid lies, right? Different liquids lie, then you cannot do it. So one such question is given: a vertical U-tube of uniform cross section contains mercury in both the arms. So this is mercury as it is written. A glycerin of relative density 1.3 of length 10 cm is introduced into one of the arms. Oil of density 800 kg per meter cube is poured in other arm. So there is glycerin, there is oil. Until the upper surface are in the same horizontal level. Find the length of the oil column. Density of mercury is 13.6 into 10 power 3 kg per meter cube. It says that suppose here we have mercury below this line, Below this line we have mercury, we have oil here, and we have glycerin here, right? So which level I will take? Definitely I will take this level to be the line where the pressures are same, because below this line, right, which line I am talking about? This line. Below this line there is only one liquid, yes or no? Only single liquid is there. So pressure at this point and this point must be same. If I come from here, and the atmospheric pressure is P naught and this height is 10 centimeter. So the pressure at this point must be P naught plus rho of glycerin. Rho of glycerin is 1.3 into 10 power 3, right? Into G into H is 10 centimeter, so 10 by 100. Right? That is the pressure at this point. And at this point the pressure will be, if this height is H, right, and this height must be then 10 minus H. So it should be P naught plus rho of oil. Rho of oil is 800, so 0.8 into 10 power 3 into G into H, plus rho of mercury is 13.6 into 10 power 3 into G into 10 minus H by 100 by 100. Can I write this equation? All of the heights are measured in centimeter. Can I say P1 is equal to P2? So as P1 is equal to P2, I can cancel P0, I can cancel 10 by, I can cancel 100 in denominator, I can cancel G, and I can also cancel 10 power 3. So I can say 10 into 1.3 is 13, that is equal to, okay, G also I can cancel, I think, yes. G also I can cancel. So 10 into 1.3, it is 13, that is equal to H into 0.8 plus 10 minus H into 13.6. So that is the equation I've got. 0.8 into H minus 13.6 into H. So it is H into 0.8 minus 13.6 plus 136, right? So that will give you 136 minus 13 is 123. 123 is equal to 12.8, I think, right? 12.8 H. So H is equal to, yes, 123 by 2.8. That centimeter. That is the answer of this question. Whatever is the calculation, you can do it. Is this clear to all of us?
Yes, sir.
I will give you another similar type of question, but the shape will be different, like this. It came in JEE Advanced. This question says a circular tube of uniform cross section is filled with two liquids of densities ρ1, ρ2, such that each liquid subtends an angle 90 degree at the center. If the line joining the free surfaces makes theta angle with the horizontal, find theta.
Sorry, sir. Rho 1 minus rho 2. So tan inverse rho 1 plus rho 2 by rho 1 minus rho 2.
Yes. Suppose this is the line with horizontal that makes the free surfaces of the liquid. If I drop perpendicular to that, then the liquids are up to this. So I can say that here lies one liquid. Suppose this is one liquid. Here lies one liquid. Another liquid lies here. Right? Here lies the other liquid. Can we find a horizontal level below which there is only one liquid? You can find this horizontal level from this one. Yes or no? Can you see below this horizontal level only this red color liquid is there? One side above it you have this red color liquid, another side above it you have this blue color liquid. So if this angle is theta, I only need the height to find out the pressure. So this angle is also theta. If this is r, then this is r cos theta, and if this is r, it is r sin theta. Right? It is r sin theta, and this is r cos theta. From here to here, it is r cos theta. For this height, I know if I draw perpendicular again from here to here, then this is r, this is theta. So this is r sin theta, and this entire is r cos theta. So I can say this height is r cos theta minus r sin theta, and this height is r cos theta plus r sin theta. Right? It is also r sin theta. So can I say rho 2 into g into r cos theta plus sin theta is equal to rho 1 gr into cos theta minus sin theta?
Yes. Yes, sir.
So g k r gets cancelled out. So rho 1 by rho 2 is equal to cos theta plus sin theta divided by cos theta minus sin theta. If I use a component to dividendo, rho 1 plus rho 2 divided by rho 1 minus rho 2 is equal to cos theta divided by minus rho 2 means sin theta. So tan theta should be, this is cot theta. So tan theta should be rho 1 minus rho 2 divided by rho 1 plus rho 2. That should be the answer of your question. Now we will talk about force by the liquid on a side wall. Before coming to this question, let us first try to understand how we can do that. Force by liquid on a side wall. Suppose we have a liquid kept in a container, and the container has a side face, a rectangular face like this. Right, so here the liquid lies. The liquid lies here like this. Now, unlike the force on the base that we have done only by multiplying pressure into area, where the pressures were same at the base. Yes or no? At a depth h, the pressure are the same at the same horizontal level, but here the pressure is not same at same level. Everywhere on this area the pressure is not same. Suppose this length is L, and this height is h. What I will do, as the pressure changes, I will take a strip, a small, infinitesimally small strip. I will first find force on this strip and then I will integrate it. Can I do it? Because if I take that at a depth say y, I have taken this strip width dy. Then every point on the strip, can I assume pressure to be same?
Yes, sir.
And what is that pressure? Rho g into y.
Y. Yes.
So that small force by that on that small strip is rho gy multiplied by the area, which is L into dy.
Yes, sir.
And all the strips will have the force in same direction. So I don't have any problem of integration. Because in vector integration, you should be careful whether the vectors are having the same directions or not. As the vectors are having the same direction, I can integrate it. Direction and the same line only, right? If they are inclined at different angles, I cannot integrate in same way. So the force will be simple integration of rho g L into y dy. Y will vary from 0 to h, and you will find it is rho g into LH square by 2. Yes or no?
Yes, sir.
Yes.
Sir,
Bolo?
sir, why can't we integrate if the vectors are in the same direction but at different heights?
Vectors are, if the vectors are not in different the same directions, I cannot integrate, because integration is means only addition, and when I am integrating I am adding their magnitudes. I am not adding their the directions in this integration. Am I going
No,
to?
sir, means after that you said that if they're inclined at means different heights but the direction is same, that time also we can't integrate.
That then you can integrate. I am only said that the forces in this on these different levels should have the same direction. Suppose you have a curved surface like this. Now on this small face the force is like this. Here the force is here. Here the force is here. Now you cannot integrate df to find out the total force.
Yes, sir.
Right? You cannot do this integration. But you can definitely do this integration here. Right? So force by liquid on side wall is given by this formula. But here different things we have assumed. One thing is that rho is a constant.
Yes, sir.
Yes?
Yes, sir.
Rho is a constant, that is why we have taken it outside. If the rho is not a constant, we could not take it outside the integration.
We have also assumed that the wall is rectangular.
The wall is rectangular, yes. That is why the integration is in this way. Okay, so we will now a very important observation you can make from here. Look, if I say that this force this force can be written as rho g into h by 2 multiplied by area. Can I do it? Rho g h by 2 multiplied by area. What is the area of this?
L into H.
L into h. If you do it, you will find the same thing. So if rho is a constant, we can use this equation. In most of the cases, you will find rho constant. That force on vertical surface is, what is rho g h by 2? I can use the formula of average here. Is it the pressure at midpoint of this surface?
Yes, sir.
It is pressure at midpoint or geometric center, you can say. Pressure at geometric center multiplied by area. Very important relation. But if rho is constant, you can only do it. In that case, it is only pressure at geometric center multiplied by the area. Right? Now, if my surface is not vertical, how do I find the force? Suppose my surface is in this way. We have a surface which is inclined with this vertical line, like this. Right? We have a surface like this. Fluid lies here. Now, if you want the horizontal component of the force, here how the liquid will exert a force on the surface? Perpendicular to it, yes or no?
Yes, sir.
But that force will have a horizontal component as well as a vertical component.
Yes, sir.
If I want to find what is the horizontal component of this force, I can simply take a projection of this area in vertical plane and find the force on this vertical plane. You will find the same force as that of the horizontal. So FH is nothing but FH can be found by force on vertical projection of any inclined surface. Of any inclined surface. Right. Again, if rho is constant, I can find the force on this vertical projection by taking the midpoint of this vertical projection and multiplying with the area of this vertical projection. You can forget about this inclined plane now. You can find the force on this vertical projection and you can find FH. Right? And if you know FH, you can easily find what is FB also. Yes or no? Because you know this angle theta, and tan theta will be FB by FH, you can find FB also. Tan theta is equal to FB by FH. So basically, if density is constant on any surface, we can easily find the net force as well as the horizontal and vertical component of the forces.
Sir?
Yes, Bolo?
Sir, I cannot visualize the figure you have drawn below.
It is only a vertical projection. You can look from, if this length is L and it makes an angle theta with this surface, then what is this height? You will take a rectangle of height L cos theta, and this base length will remain the same. Now you can find the force on this rectangle which is having an area of B into L cos theta.
Okay, sir.
Right? It is only a vertical projection. If you project light from this horizontal direction, then whatever is the shadow on vertical plane is the vertical projection. Have you got it?
Yes, sir.
Okay, we'll find few questions, then I think it will be more clear to you. For the time being,
Sir?
you should know these parts. Yes, Bolo?
Sir, for the horizontal component,
Yes.
no, sir, for the vertical component, can we use the projection on the base?
No. we can use the free body diagram also to find out the vertical component. We will do that in later parts. We will do that. To find out the vertical component, we can use the free body diagram. Not we can use the projection at the base. Okay. All right. We'll do that. First, try to solve this question. It says in a cubical container of side 10 meter, two immiscible liquids of 1000 and 2000 kg per meter cube are kept up to the same depth 5 meter each. Find the net force on any side wall. Suppose this side wall I am asking by the liquids. Also find the height from the base where we can assume the net force is acting. Look, if I first find the force on this one, this suppose this is the entire wall. Right, I have taken up to this one. The force is only rho g into half of that is h by 2 into area is 10 into 5. Yes or no?
Yes, sir.
What will be the force at this point? Look here, the force cannot be found by this equation because the pressure at this is not 2 rho gh. The pressure at here will be rho g into 5 plus 2 rho g. The pressure is what? At this point, the pressure is rho gh plus 2 rho gh by 2. Yes or no? Multiplied by area.
So how is the equation like this?
I have said that the force on a vertical surface, how do I find the force on a vertical surface? The pressure at the center. What is pressure at the center? Pressure at this point is not 0. Here the pressure at this point was 0. So I have just added 0 plus rho g into 5 by 2. But pressure at this point is already rho g into 5. Plus you are moving downward with 2 rho g into 5 by 2. So is it the total pressure at this point?
Okay, sir.
Right? So net pressure multiplied by area. So this is force F1 and this is force F2. Right? Definitely the forces are not passing through these points. That I am taking for the center for the calculation of pressure only. So F1 is equal to F1 plus F2. Now that is equal to, it is 10 into 5 into rho g if you take common, rho g into 50 if you take common, rho g into 50. So it is 5 by 2, 2.5 plus rho g into 50 plus 5 plus 5. So 10 plus 2.5, it is 12.5. So it is 12.5 into 50 into rho g. Rho means 10 power 4, right? So it is 62.5. Yes, that is the answer. Into 10 power 5 Newton. That is the net force. No one of you could find the answer. Even if it is at some depth, I have to accurately find what is the pressure at the center. Then multiply it with area. That is the force. Now, how do I find the point of application of the forces?
So, by applying the principle of moments.
Yes, by applying the torque equations, you can see that point of application of the net force, suppose if it is here, the F net, if I say F net is here, F1 plus F2, can I say that the torque of this net force about this axis should be the same as the torque of individual forces about this axis? Yes or no?
Yes, sir.
So try to understand the equation that I am going to write now. Torque of the net force, which is 62.5 into 10 power 5 into, suppose this distance is y. That is equal to, what is the center of this force, that also I do not know. What is the center of F2, that also I do not know. So what I will do, I will take, here again you have to take small area, right? No other way is there. One way is there that I can explain, but if you take a small area, suppose this height is h, so let it be h, and small area at y at a dy, then this is rho g into L dy, rho g y into L dy. It is the force, and what is the distance of this force from point O? Is that distance 10 minus y? Yes or no? Can I take this torque from y equal to 0 to 5 meter? And in the second case, if you take a suppose x from there, then the pressure at this point is rho g into 5 plus 2 rho g x. Then it is 10 into dy dx multiplied by the distance from the base is 5 minus x. This integration is from x equal to 0 to 5. Instead of L, you can take it 10. So this equation will give you the value of h. Have you got this? हाँ बोलो.
Sir, can we directly say that F1 will act to the geometric center of that
No.
first layer of liquid?
No, F1 will not act at the geometric center here, or F2 will not act at the geometric center here.
So why F1 will also not act? F2 it's okay, but F1 also.
F1 will also not act. Why? Because if you see that how the pressure is gradually changing, the pressure is linearly increasing, right? So if this is the vertical wall, you can see pressure here is 0, pressure here is increasing, right? So pressure is gradually increasing like this. If you think about the pressure at this line, so if you strictly join this line, what you will get? You will get a triangle, right? So if I ask you what is the, from where the net pressure is acting, then you should not answer the pressure with this area of rectangle, but you should answer from the triangle. It is acting at the center of this triangle where this height is h by 3. Right? It is not h by 2. So that is also known as pressure triangle. That is not important actually. If you know this equation, You can also find it. But you should know that pressure is gradually increasing and it will form a triangle. At the center of the triangle, you can actually take the pressure. Now, if you calculate it, you will find your answer, right? So rho g into 10, rho g into 10, you can take outside, and it is 10 into y dy. 10 into y dy means 10 into y square by 2, 5 square, minus y dy means y square by 2, right? And plus this one is rho g into 5 into 10 into 5 minus x dx. I think we have done wrong calculation here. It is 10 into dy only. 10 into dy means 10 into 5. 10 into dy minus y dy. So it is also 5 into dx. 5 into dx is
5 into 5.
5 into 5 minus x dx is x square by 2. Plus twice rho g into 10, and then it is
Sir,
okay,
the first
yes,
term was,
first term.
it should be square by 3
Yes,
and then
yes.
cube by 3. Square by 2 and
10
cube by
y
3 because
dy
there is a y also.
means 10 y
Yes.
square by 2 minus y cube by 3, and this is also 5 into 5 into Achha, this is correct. I think this is correct. In the second term it is
Yes, the second term is correct.
5x dx, so 5 into x square by 2 minus x square dx x cube by 3. So it is a lengthy calculation indeed. Right, rho g into 10, rho is 10 power 3, g is 10 and 10. So 10 power 5 I can cancel. Right, rho g 10 is 10 power 5. So 62.5 is equal to 5 into 5 square. That means 5 cube, 625. 5 cube is 125, right? Minus 5 cube by 3. So 5 cube in minus 5 cube by 3 is 2 by 3 into 5 cube. Plus 5, again it is 5 into 5 into 5. So it is 5 cube minus 5 cube by 2. So it is 5 cube by 2. Plus 2, if you can cancel, it is 5 cube minus 2/3 5 cube. So it is 1/3 5 cube. 2/3 5 cube plus 1/3 5 cube is 5 cube plus 5 cube by 2. I think it is 3 by 2 into 5 cube.
Yes, sir.
Yes, sir.
So the value of h is equal to divided by 62.5. It is
So it is
2.
3 meter.
3 meter, yes. So from the bottom, h is equal to 3 meter. It is the height of the effective force, right? So that you can solve in this way. And also, as I have told you, that if you draw the pressure diagram, this force will pass through the center of this triangle, and in the below segment the pressure diagram will be something like this, right? This pressure is 3 rho gh.
So would line be more inclined?
Yes, this line will be
So it will be more inclined as the pressure
yes,
increases
yes,
more
yes. It will
drastically.
be more inclined. Yes, it will be more inclined. And the center of this you have to calculate. F1 will act from here and F2 will act from there. Then you can take the discrete forces and just calculate the net force. Right? But that also takes some time. So in this will always take some time to calculate, right? The idea is that the net torque about this point should be zero. Of all the net torque should be the same of all the forces and the net force. Then that is the point of application of the net force.